Hi, today I'm going to be using kinematics to see how far away a Hot Wheels car rolls from a cliff based off its mass and the initial angle. I'm going to be placing this 3-foot descending slope at different 15-degree increments on this pegboard I made. Then I'm going to see how the slope and mass affects the change in the x-axis as the Hot Wheels car descends 2.5 feet on the y-axis. The independent variables of my experiment are the slope and the mass. However, the dependent variables are the change in x as the Hot Wheels car falls. For my first trial, I'm going to see how far the car goes when the ramp is at 15 degrees. And now, 30 degrees. 45 degrees. 60 degrees. And finally, 75 degrees. Now that I have my measurements for this car at different angle degrees at this mass, I'm going to add some weight and see if it changes my results.
What you doing? Where you at? Oh, you got plans. Don't say that. I'm sipping wine in a robe. I look too good to be alone. My house clean, my pool warm.
So now I'm going to do the same thing again, but with extra mass. So here's 15 degrees. 30 degrees. 45 degrees. 60 degrees. And finally, 75 degrees. So I took all my data and I put it into this nifty bar graph titled Angle of Ramp versus Change in X. I modeled my data from mass 1 in blue and my data of mass 2 in orange. However, I thought this wasn't the best way to represent my data because I used feet for my unit of measurement for change in X when I should be using the customary unit, meters. That's why I turned it into this handy dandy graph titled Angle versus Change in X. I put all my data into Logger Pro and got these slopes. Then I just put them into my graph. And as you can see, there is a definite linear relationship between the independent variable angle and the dependent variable change in x, now in meters. Because there's a definite linear relationship, we can conclude that the angle of the slope, as in like how steep the ramp is, does have a significant effect on how far the car will travel from the top of the cliff to the bottom. However, I took the slope of mass 1 and subtracted the slope of mass 2 from it, then divided that by the slope of mass 1 and multiplied it all by 100, and I got an 11.11% difference. Typically, when we do calculations like that, that would be considered significant. However, because the slopes are so minuscule, I'd say that an 11.11% difference is insignificant, and we can say that mass does not affect how far the car will travel from the dresser. So we've determined that mass doesn't affect the change in x, but the angle of the ramp does. But what is that relationship? So we can see in this graph that as the angle of the ramp goes up, the change in x goes down. This means that the higher and higher, or the steeper the ramp is, the less the car is going to travel from the top of the cliff on the x-axis. These results make sense because the smaller the angle of the ramp, the smaller the tangent of the car is going to be. This means that it's going to have more horizontal velocity when it leaves, and it will cover more ground on the x-axis per second, and it's going to have less negative downward velocity, meaning gravity is going to take more time to bring it to the ground. Also, the potential energy of the car when it's on the top of the ramp is going to be mgh, and its kinetic energy when it leaves the ramp is going to be 1/2 mv squared, assuming we consider height to be 0 there. Now, we can just cancel out the mass from both parts, and therefore mass shouldn't and didn't have an effect on the change in X for the car. Although I tried to make the experimental design as good as I could, there may have been some errors, especially considering how small the ramp was and how small the distance between the bottom of the ramp and the floor were. There could have been so much room for error. I was also limited because I didn't have a scale small enough to measure the actual mass of the car at home, so I just have to have mass 1 and mass 2 being the lighter and the heavier one, which isn't very exact. Although I was limited at home, I think I was effectively able to prove that the angle of the ramp, as long as it's between 0 and 90 degrees, has a negative relationship with the distance in X that the car covers, and the mass of the car should have no effect on the actual distance that it covers. Thank you.